and welcome for this talk about rapid prototyping. So my name's Iain Hensey. I am the Clinical Director of Innovation at Alder Hey, one of the surgeons there and one of the co-founders of the Innovation Department. Now I'm going to be talking about rapid prototyping because this is an area which is particularly close to my heart. I basically love doing this. This is where I work. Just in case you haven't seen any of the other talks, you don't know anything about Alder Hey, you've just jumped in. This is Alder Hey. This is the Ferrari supercar of the children's health world. That is grass going up onto the roof. Is that cool? And underneath the third wing, we have our innovation hub, where we do a lot of our rapid prototyping. Now, so this is me here. Sorry, just up there. Now, what I'm doing here is I'm testing out a new type of operating microscope. And this type of operating microscope often would be brought into hospitals and surgeons would be allowed to use them, but they would use them in live operative situations, whereas I prefer to try new bits of technology in a simulated environment. So we're using a 3D printed simulation model in this picture here. I don't know if you can see it just there. 3D printed model there to try it out, just to quickly test a bit of technology in a completely safe environment to see what merit it has. And I think that actually is the essence of rapid prototyping. It's about safety. I've talked about this before. How do you create trust in the innovation process? How do you get people to take that next step? And it's about creating these safe environments. So for rapid prototyping, basically there are three groups of people I find in innovation when you're trying to get things done. And there are people that just get it. You give them an idea and you don't have to even show them. They get you in the first couple of sentences, like, you know, monkey tennis, or you just say something to them and just like, oh yeah, I see where you're coming from. I can see how that would be good. And then, but they're a small proportion of the hospital population. There's the group that get it if shown. So this is the people that really the prototyping comes into its own. If you can show them a potential solution, even if it's a rough kind of mock-up of it, they kind of get it. And then you can bring along on a journey with you. And then there's the people that are just never going to get it. So, you know, you can try all you want, but you know, they're not really going to be open to the new innovation. Even if you show them it, they're not going to get it. But they're actually a small proportion of people. Most people are in this central zone that kind of get it if shown. And that's why prototyping, I think, is such a useful methodology in innovation, because it allows you to get things into people's hands. So in our innovation hub, we have this place called the Rapid Prototyping Centre. And the purpose of the Rapid Prototyping Centre is just that. I like thinking more as like a really advanced crafting zone. You know, we have work tables, and we have some instruments, some basic electronic instruments, things which can make simple models with some CAD design software, some vacuum molders, some 3D printers, laser etchers, and you can knock something together is probably the best way to describe it. And it's quite a nice zone in hospital to go, right, guys, let's just try and make something. One of my funnest teaching things I did with the students was we basically went to the pound shop, bought about £90 worth of various stuff, and we just dumped it all on the table. And we said to these groups of students, right, make a simulator. Give me any simulator, and the best one wins, and we'll judge it. Very, very loose. And he just got to work, you know, getting all this stuff together in the prototyping center. And you wouldn't believe the quality of stuff which they actually came out with. Some really amazing simulators. I particularly like the one for looking a lung simulator made out of lots of balloons. So it was just fantastic. And it's that type of process you want to get people into, just kind of, let's just put it all together. So there's a neater picture of it. So as you can see, nothing particularly fancy, but you know, I found to be amazingly useful in getting the creative process going. Now, during COVID, that Rapid Prototyping Centre, we brought it online 2019 just before COVID. During COVID, it came into its own. I basically camped out down there because problems were being brought down from the hospital. People were just coming down and saying, oh, we need to have this fixed. We need to get around this. We need to try and solve this problem quickly. They knew we were the people to go to. They came down to us and we did something stupid like 46 prototypes over the initial COVID period, 12 of which got deployed and 4 got commercialized. So, pretty impressive hit rate, really, just from the act of got a problem, some basic tools, let's get on and fix it. Here is one of my favorite ones, one from the early stages of the pandemic. So when this broke out, it was all about contact spread. Everyone's worried about contact spreads, don't touch the door handles. It's like that game, the floor is lava, but it was like the door handles are lava, don't touch the door handles. And we'd previously actually had this thing with our 3D print partners, 3D Life Prints, around a children's competition for things that could work on the space station, things you could 3D print in the space station. To reduce the level of infection, because apparently space stations are very dirty places. The bacteria really enjoy the zero gravity. And I'd had this idea for like a 3D printed copper impregnated handle that the astronauts could carry around with them that would fit over the door handles, and they could open and shut the doors. And they would only have the personal handle, therefore they wouldn't spread infection. There's a children's competition, so I didn't enter it. But when the pandemic kicked off, I was like, right, okay, how could we adapt that to the hospital? So, right, what do we carry around us all the time? ID badges. Could we modify an ID badge so that it would open doors? So you can see the very first one there, 3D printed it with 3D Life Prints, and it worked okay, but the hook wasn't quite right, wasn't quite gripping the doors, a bit fragile. So we kind of beefed the hook up. You can see here. Still, and the hook just kept on snapping, and then we realized we didn't actually need a big hook. We could put in a small hook, because even with the hook snapped off, it still worked very well. So we did that, and then we thought, right, we need to test this more around the hospital. So we did a big batch run of these ones, and then all the hooks snapped off because what it was made out of was very brittle. So right, okay, how can we make it not brittle? So we made it out of a different material, and it was better, but we couldn't make it in the volumes because we wanted to make lots of them. So we eventually ended up creating an injection mold to make these door openers. And I'm going to try and show you here. So this is the final injection mold of what we called the distancer, which was this hands-free door opener. So you see it slamming together like that. And we made thousands of these, and we put them all around the hospital, and we gave them to all members of staff, and we actually started selling them to different places. And then unfortunately, contact spread wasn't actually the big thing, so that it reduced in its popularity. But it was just a nice example of how rapid prototyping can do things really quickly. So we went from a standing start of having just an idea to something which is on Amazon shop within 3 months. So that was, a great example of the rapid prototyping methodology that we used. Here's another one. Now I'm not getting from Disney here, but another problem was the visors. Now we actually made loads of the standard visors in the Innovation Hub, and using standard design would be 20,000 with some of our manufacturing partners. However, we thought, right, okay, this is too slow and it's too expensive. Is there a way we could make these really, really quickly and really, really cheaply? So we created something which was a little bit like a Star Wars helmet. This plastic visor out of the same process that, the thermomolding. We had the thermomolder in the hub, but we went to a specialist food packaging company, the type of people that make things, for Easter eggs, to thermomold and vacuum mold these visors, so make them highly recyclable. Made it one piece. We made it at an incredibly high rate, So here we go. Here's another video again of these things firing off the assembly line. We can make, I think it was something stupid like 30, 40,000 of them a day. So we never got anywhere close to running out of visors all day because we had such an efficient process for it. This is what it looks like when they were on members of staff. If you're wondering why the hamster cheek bits are on it, it's to help release the hot air. We did have it narrower, but it was just retaining the hot air too much, and we found that through the prototyping process. Another one of my favorites. So again, we picked very early that face coverings were going to be a big thing in the pandemic, and we thought, well, wouldn't it be great if we could make our own one? We could give it all to people coming to the hospital. So we did. So this is one of our surgeons, Roland Partridge, and he just started knocking things together because we've got a sewing machine in the rapid prototyping center as well. And he started putting together all of these different, prototypes of masks. But then what he did, and this was the impressive thing, is he went off and he found some manufacturing partners. He found the last cotton mill in the UK, which is still running. He sourced all the manufacturers and the designers, and we eventually got this mask onto the then Health Secretary's face. We sent samples up to them, and we did a commercial partnership with them, with Brilliant Masks as a company, and we sold loads of these, and hundreds of thousands of them, and made quite a lot of revenue off it, which we could feed back into the innovation process. Again, member staff had a good idea. We enabled them to quickly make prototypes, see which ones would work, and a great result all round from our point of view. Here's another one. So I am useless at vascular access. Vascular access is something I'm not particularly good at. And this is one of our trainees over here, Chun, who had this idea around 3D printing a little simulator so that we could practice using ultrasound machines to get a needle into a vein. And he'd already started working on this idea in a different hospital, but the problem he had was the gelatin element of it to mimic the tissues used to get really moldy. So we started working with him on how to create a material that could be poured in that wouldn't go moldy. And we created one, it's secret, but we created a very accurate material for mimicking ultrasound procedures so that people can practice doing intravenous access. So that is great fun. So this is one of our biggest ones at the moment. This is our Clear Mask project. Now, this is Wendy, who's one of our speech and language therapists, and she came to us, to the innovation department, and said, look, I've got a problem, I can't do my job, because if the patients can't see my face, I can't teach them how to move their lips. I can't, give them any sort of feedback into how to speak. So I need some kind of clear mask, and the clear masks in the market are no good. So took that challenge up, and again in the Innovation Rapid Prototyping Center, not together this incredibly noddy design for moving the mask element down. So then we took this prototype and sit and showed her, said, it's the sort of thing you want. She said, yep, it's the sort of thing. Right, okay, we went to designers, we worked up all sorts of designs, and then came with this CAD. We then took the CAD design and we got the design rights behind it, and we then took it to a manufacturer. And we did a partnership with Blue Tree Medical Group, and they are now putting this through all the various safety standards. We've got Type 2R safety standards all been approved, and that's now going on to all the procurement frameworks. So again, problem, quick prototype, and move it into potential commercializable. And it was so complicated as well. I thought it was going to be too easy. But the complexity of making medical devices really is, to be honest, off the scale. I mean, look here's like all the different prototypes that we went through trying to make this. And this is it being sold at a stand in Dubai at the Arab Health Conference. That's me up there in my kind of early modelling career. But it showed the power of the innovation process, because this wasn't just about design. There was a huge amount around the contracts and the commercialization and negotiations that went alongside getting a good partner in. Another thing which is great for rapid prototyping is to prototype an operation. So this is one of our orthopedic surgeons, and he had the sort of operation that you lose sleep over. The one where we're like, oh, I'm not sure if we can do this. What's it going to be like? What's it going to be like when you get in there? There's most operations, you feel relatively relaxed about, but there's a lot that are very complicated that, there's a huge amount of anxiety associated with it. So 3D Life Prints, who are our partners here, they can make this really good wood pulp mix which mimics bone. So he could come down and he could practice doing all the various cuts in our kind of crafting area on the model, and then see how the screws and implants and plates would go with it. And it was great, because I saw him afterwards. He was so happy. He's like, yeah, this is going to work. And he's like, I'm going to go and x-ray this model now and see how it all lies together. It's great. It allowed him just to, get his hands on it, feel it. That's surgery is a very, hands-on type of speciality. Here's more with 3D printing, and that we actually made a lot of these models sterilizable, so that you could take the model in with you to theatre. So you could use it as a reference point. And then here, this is a lovely story behind rapid prototyping. So these are two of our top oncology surgeons, Joe and Fiona, and they've been approached by an ex-member of staff, actually, whose child had a very unusual tumour. You can see it on the MRI scan here. Huge, and all the main blood vessels to the legs were going through right to the centre of the tumour, and the national bodies weren't sure if it was resectable. And they came to say, look, could you print it out, just so we can look at it and feel it, and take it to other teams in the hospital and get their opinion and see if we could take it out. And we printed it really quickly. And it was great, because I watched them go around the hospital, build support for doing this operation and taking on this this horrendous tumour. And we're very glad to know it was very successful. That's her 6 weeks after the operation. They got well over 95% of it out. Great success story to be able to do that through the power of mocking up what you're going to be dealing with, what your operation is going to be. So here is, they're not all fancy, they're not all kind of high-end, complex oncology prints. Now I point out that now for all the complex oncology operations, they now get a print. This is a simple one during, again, the height of the pandemic, when everybody was getting their glasses steaming up. I thought, we could use this like this nano tape. It's like an adhesive to stick the masks onto your face, and that way you wouldn't steam up your glasses. And I was showing this to one of my trainees, and she was like, well, there's another type of tape that you can use to stick things onto skin. I said, oh, what is this? So, oh yeah, I think the correct name is lingerie tape. It's used for fixing dresses. And I was like, okay, so there we go. We bought it in through Amazon on the Rapid Prototyping Centre cost code. And then all of a sudden, everybody in the hospital is using it to stick the masks onto their faces so that they got no steaming up of their glasses. Very easy fix, but it improved, because we were losing staff at the time. We were having to go off work because they'd been exposed to a case and they hadn't been wearing eye protection because of the steaming. So that's what it reduced. Oh, I love this story. So this is, I don't know if you can see him there. This is Lewis. And Lewis is great kid. He's one of the ambassadors for our charity, and he has 4 fingers. And his mum got in touch with me saying, look, Lewis, he loves mountain biking, he loves going out with his friends, but it doesn't fit the bike very well, and he's getting lots of rubbing. We can't find any gloves that fit him. Could you guys make gloves for him? So we're like, right. So one of our innovation consultants went out and found this high-end mountain bike company in Jura, who then custom made him, you can see here, custom made him some some gloves, some mountain biking gloves. And what I love about this is that the tweet they put out from Lewis was high fours all round, because that's one of his sayings. So I thought that was absolutely brilliant. Now, the thing about rapid prototyping, I've shown you some of the success stories, doesn't always work, and that's great. So this was one of my ideas around trying to create this kind of airflow system, which would just blow clean air just through a mask type thing. Because the problem with the hoods was that you couldn't hear very well. I thought, well, if you just blow over your face. So I created this contraption, and it just totally didn't work. It was useless. And in fact, I'd created a system by which it would provide an extra puff when you breathe in, stop anything from being entrained from the outside, but actually just recycled carbon dioxide. So it's great to have figured this out early before I tried it out on anybody else. And also it didn't particularly filter very well either when I tested it on our particle count machine. So but it's good to learn early. So that was one of the advantages of rapid prototyping. Another thing which didn't work, this was well, actually, not that it didn't work. It more wasn't a problem, which is a big thing, I think, with innovation, is that you often go out and you solve a problem that isn't really a problem. And it was, again, start of the pandemic, we were really worried we're going to have like Bergamo type levels of, not having enough oxygen points in the hospital, running out of oxygen, being completely overwhelmed. We thought, is there a way that we could get 3 oxygen feeds off of 1 oxygen tap? So we 3D printed a 3-way splitter. So we made this, and I remember speaking to the head of medical engineering. He just looked at me and said, there are 800 oxygen points in the hospital, and we've run the hospital system at 700%, and it can handle it just fine. It's kind of like, Scottian engineering from Star Trek. You can handle it, Captain. And he was like, so we're not going to need this. And he was like, no, given we have 300 beds and 800 oxygen points, and we were never even remotely near that level of saturation. This is an example of how prototyping isn't always necessarily small things. It can be big things as well. And we were building this new neonatal surgical unit, and we want to put in lots of new things in it. And the trouble with new things is that people are always very nervous about new things. And because they don't get it, when you try to explain something, they just like, well, let's just not do it. So we created this space in our innovation hub where we printed out all the floor plans for different rooms, and have put lots of new types of different tech in it, and also new kind of ways of arranging rooms, and how we could have parents staying with their babies, and how we could have ways that the nurses might not have a direct line of sight, but would have sight of a high resolution video camera. So trying to get the teams down and letting them look at the setup before they actually have to use it. And that way we can get buy-in, and people will feel more empowered to go, okay, maybe we could try it, because actually it's not so bad, is it? Because they can stand in it, they can feel it. And it's much better than showing someone like a little plan. You've got to be able to get them to stand in the space and look around and go, yeah, actually maybe we could do it this way, and run some simulations of the clinical procedures. So what I hope you take away from this is prototypes. It's a great tool for innovation. It makes things easier to explain. If you're trying to get something across, it's great for reassuring people. It's like, look, it's not so bad, is it? Or this actually might be quite good. And it allows people to coalesce around a problem, because people coalesce around a physical thing better. And they can see it, and they can work on it, and they can iterate on it, and it's safe. You're in a simulated environment, you're in a prototype environment. It's a very safe way of doing it, and as such, people are more innovative when they feel safe. And it's a key component of what we do, is making people feel safe about what they're doing. So that's a quick whirl through on rapid prototyping.